Alright, so in the last video we ended looking at the two, what I call special cases, the no solution and then the infinite solution, or the all real numbers. And that's what we ended with last time. So let's just take a look at this, just adding to our repertoire, I guess I could say, of equation solving. So we're just going to kind of get warmed up in this video with just an equation. Maybe it'll be one of the special cases, maybe not. So let's just kind of start with a equation that's like ones we've been looking at. So 8 quantity A minus 2 minus 3 quantity A minus 3 equals 14A minus 7 times the quantity of 2A plus 1. Alright, so let's start by simplifying each side. So on the left I'm going to have some distributing of an 8, and then in the second set of parentheses distributing through a minus 3. On the right-hand side, some distributing here of a minus 7. All right, so what do we have? 8a minus 16 minus 3a, being careful on this sign, plus 9, equals, on the right-hand side, 14a minus 7 times 2a is 14a. Again, be careful on your sign here, minus 7. Okay, so again, before you start adding and subtracting numbers to both sides, pretend it's not even an equation right now. Just work on simplifying each side down. Treat it like a little mini simplification problem from 2.1. So 8a minus 3a is going to give us 5a. And then combining my plain numbers on the left, negative 16 plus 9. So that's going to, different signs, take my difference, which is 7, give my answer the sign of the larger number, which is minus. So 5a minus 7. All right, now on the right-hand side, I also have some like terms that I can combine. In this case, they're going to just become 0. 14a minus 14a is gone. It's 0. So all I'm going to really have left, so I can just kind of put lines through those. All I really have remaining on the right-hand side is 0 minus 7, which is just minus 7. All right, so if we're at this point, I have an a term and a constant on the left, and then I just have my constant on the right. So notice this is not one of those two special cases from last time. So let's just observe that right now. The special cases are when the variable drops out. I don't have that here. I have a 5a, and the variable term is not dropping out. So this is not one of those special cases, even though students often confuse it as one. That's why I'm doing this example. All right, so focusing on, like if I'm focusing on here, like I'm trying to get the a alone on the left-hand side, first thing, there's a minus 7. What would I do? I would add 7 to both sides. So that is working my way into this a here on the left-hand side. So I have 5a equals, now what do I have on the right-hand side? 0. And that's okay. 0 is a number like any other. And so I'm almost done. This is really just like a usual equation. It's just that we ended up with 0, which feels unusual. So I'm down to my last step, 5 times a. We do the opposite or inverse operation, and we divide both sides by 5. And remember, 0 divided by a number is perfectly fine. That is simply 0. So this is not no solution. It's not all real numbers. It's just 0 is the solution on this one. So I wanted to do one with that because students often confuse that with a no solution situation, or one of those two special cases. All right, so number 2. We're going to start to transition into kind of our last major type of equation situation. I want to focus on our equations with fractions. And so we're going to start to transition into that. I'm going to start with kind of a shorter example. So suppose we have 3/5 x is equal to negative 15. And I want to talk about this in a variety of ways. All right, so if I'm teaching in class and I'm asking students, what would you do first? A typical common response I get from students is, well, if when I have 5a I divide by 5, if I have 3/5 x, it's being multiplied by the x. Most of the time I have students that will say, let's just divide both sides by 3/5. And guess what? that is mathematically correct. But if I'm giving you a quiz or a test without a calculator, often what might happen is over here on the right-hand side, I would have students that might get stuck with the appearance on the right-hand side. So this right-hand side, it looks a little bit ugly. So this maybe looks, a little ugly, let's just say. Now, if we're doing this without a calculator, I'd have to know what this meant. So this requires me, so in this approach, here's what I'd have to know. I'd have to know that dividing by a fraction, even when it's written in a way that I'm going to call a vertical way, is the same thing as a problem that you're more traditionally used to seeing written horizontally. That might look more friendly. But the big fraction bar is the exact same thing as a division sign. So negative 15 divided by 3/5 written vertically versus written horizontally. And in both cases, what we have to know is dividing to divide fractions. We reviewed fractions. We multiply by the reciprocal, and maybe thinking of this as negative 15 over 1 would be helpful. So you'd have to know that, and we haven't really gotten to that type of representation of fractions yet. We will, but you'd really have to know that with this approach. And so it is okay, and if you knew this, then you'd be fine. What would I continue to do here? Well, either multiply numerators and multiply denominators and reduce, or you can do a little cross-canceling first. The 15 divided by 3 is 5, or 3 goes into 3 once and into 15 5 times, and then multiplying what's left there is a negative 25. So we would have to be able to do that operation. So it's not that this is wrong, but it does look a little ugly, and a lot of students without a calculator might get stuck. Okay, so let's talk about this in a different way, and a way that is going to look a little bit nicer. So let's return to the original problem here, and let's think about maybe even doing this in 2 steps. So suppose I said to you, let's focus on how would I get rid of this 5 first. All right. Well, let's think about this. This is something being divided by 5. That's what that fraction bar is telling us. So if we were going to do the opposite operation, that's what we do, inverse or opposite operations, we would have to multiply both sides by 5. Now, again, if it helps you when you're looking at fractions, think of that as 5 over 1. But the whole reason we did that is to reduce those 5s. So now on the left-hand side, we would just have the 3 times the x, so 3x. And on the right-hand side, negative 15 times 5 would give us negative 75. And now our last step is down to something a little more familiar. To get rid of that 3 times x, we divide by it. And so dividing by 3, we're going to have our, of course, same answer of negative 25. All right, so that's another approach. And then kind of one final approach, which I think is really the culmination of thinking about these things in a couple of different ways, and this one's probably going to be the easiest. So if you get to a situation where you have, again, just a fraction times a variable, we can basically do what we did in step 1 with the representation, or what we did in the first time we solved it up above. We can do that division by 3/5, but kind of using the representation of what we did in the second attempt. So rather than multiplying by 5 and dividing by 3 in 2 separate steps, we could do that in 1 step right away. So let's multiply by 5 and divide by 3 at the exact same time on both sides. And now we're to something that looks like the work you have kind of right above this here, the negative 15 times 5/3. So to me, this is the most superior way to do this. It looks the nicest and it takes care of it in one step. But now this only works if you have something where you're down to just a fraction times a variable. So on the left-hand side, that's 15 over 15. That's just 1x, which of course is just x. And then on the right-hand side, once again, we're looking at negative 15 times 5/3. However you like to think of that. Of course, we've done this a couple times already. You're going to end up with negative 25. So for my money, if I was going to pick the technique that I like best out of the three that we did, it would be this last one. So I'm going to give that a little extra circle. But you can kind of see there's multiple ways to go about this. Now, what we did though actually in the second step is going to generalize better to our equations with fractions procedures, and that's what we're going to have on this next page. So this was an easier example where all we had was one fraction times a variable. And so we just had to get rid of that 3/5 and we were going to be done. So this is going to be a little different. So what we want to now start to kind of think about, so I'm going to write an example down below to kind of just illustrate for you how this is going to change. So suppose it's just not quite that simple. So suppose I have maybe several terms, maybe a couple of them have denominators. So in this case, I have a couple of denominators on the left-hand side. They wouldn't have to be. You could have one of them on the left. I could have put the a minus 1 over 2 over on the right-hand side. I mean, it doesn't matter. But in this case, they both happen to be on the left-hand side. All right, so here's what we're going to do. We are going to multiply both sides of the equation by the lowest common denominator. So what I want you to remember is that the lowest common denominator is the product. So the product of the denominators would always work. It wouldn't always be the lowest. So in general, to find this lowest common denominator, which is the least common multiple, one approach is to write out the multiples. I can write out the multiples of all of the denominators. So all of the denominators that you see in the equation, you can start to write out their multiples. And then the least common multiple, you're just going to take the smallest number that appears in all lists. So take the smallest number that's in all the lists. That is technically the least common denominator or the least common multiple. But the other thing I'm going to kind of say here is, and it would always work, when in doubt, simply use the product of all the denominators. It will always work. It just may not be the smallest number. You may have a little more reducing to do, but when in doubt, just take their product. So we're going to multiply both sides by that lowest common denominator. So let's take a look at this example as we're going through the steps and think about it here. So I'm looking at the denominators of 5 and 2, and the lowest common denominator is 10. So certainly if I went off to the side and I thought to myself, okay, I'm going to look at the two denominators here are 5 and 2. So if I wrote out the multiples of 2, it would be 2, 4, 6, 8, 10, and so on. And if I write out the multiples of 5, it's 5, 10, and so on. So we are taking the smallest number that is in both lists. And so that's one way to get there. When in doubt, 5 times 2, in this case, happens to be the lowest common denominator. That 5 times 2, that product, will always work. It's just sometimes you might have missed something smaller. So when in doubt, take that product. So in this case, the product is perfect. It is the lowest one. So 10. So we're multiplying both sides by that 10. Now, second step, this is key. We have to distribute before we do any reducing or canceling in the denominators. So we are going to distribute through this 10 to both terms. We have two terms on the left-hand side. Your terms are separated by that big old subtraction sign there. So two terms on the left. On the right-hand side, of course, there's just the one term. But on the left-hand side, there's more than one term. So what is this going to look like? It's going to look like we're going to have this 10. And for a lot of people, putting this over 1 will be just a little more user-friendly since we're working with fractions. So we're going to have 10 times the first term minus, and again, we're going to have this 10, and if it looks a little nicer to you, put it over 1, times, and then that second term as it was, which was the a minus 1 over 2. And then on the right-hand side, of course, we just have the 2 times the 10, so you can just make that 20. All right, so we've distributed it through to all the terms. Now that we've done that, the third step is to cancel or reduce the denominators. Okay, this has really been our goal all along. So the idea is we want to get rid of the denominators. So getting rid of them is kind of our big goal here. And so that's why we're multiplying by the lowest common multiple or least common denominator. It's the same thing. All right, so we look at the 10 and the 5. The 10 divided by 5 is 2, or if you like to say 5 goes into 5 once and into 10 twice. In the second term, remember, multiplying fractions is the only time you get to do this kind of cross-canceling with denominators. So we're reducing. We're doing the 10 divided by the 2. That gives me 5. Or 2 goes into 2 once and into 10 5 times. And now notice all of my denominators are 1s, so I have cleared all of the denominators. That's perfect. So with the fractions now cleared, we're going to solve as we normally would. So let's take a look at what we have. So we have 2 times, and then we still have that a in that first term. And here I need to be a little careful. So I have this minus 5, but there are implied parentheses around numerators and denominators. So I still have minus 5 times the quantity of this a minus 1. And that is really, really crucial because in this next step here, and if you skip what I just wrote out, you still have to be mindful of this if you went right to this next step. You're distributing through this negative 5. So first of all, it's knowing that there's those implied parentheses and you have to distribute, and then making sure that you're grabbing the minus with that 5. So we would now have 2a minus 5a plus 5 is equal to 20. And now it's old hat, right? So we're just combining like terms. We're doing some simplifying here on the left-hand side. So we have 2a minus 5a is minus 3a. And now each side is as simplified as it can go. My a term's on the left, so I'm going to go ahead and get my constants on the right. So I'm going to subtract 5 from both sides. And so when I do that, I now have negative 3a is equal to 15 on the right-hand side. And so my last step here, it's negative 3 times a. So we are going to do the opposite operation here. So dividing by that negative 3. And now we get negative 5 as our final answer. Okay, so again, we can always plug these back in and check them. I haven't been checking all of my solutions, but just for kind of good practice here, let's check this one. Maybe that one seemed pretty complicated and I'm not sure if I got it. So I'm subbing negative 5 in for a. So negative 5 over 5 minus negative 5 minus 1 over 2 equals 2. All right, so negative 5 over 5, that's negative 1. The second term, negative 5 minus 1, that's going to be negative 6 over 2. So that's going to be its own little -3. And then minus that -3 is going to change that into a +3. And that looks good. -1 plus 3 is 2. 2 equals 2. And that worked out. Sorry, I was off my screen there for you, I think. So this one definitely checks. And we are able to see it does work. Okay, so when we come back in the last video next time, we're going to do another equation with fractions, and then there's kind of another approach that you can sometimes take that students like to do, and I'll mention that next time. So we'll have a couple more equations with fractions in the next video.